Hi everyone, and welcome to this tutorial. My name is Hugo Affaticati, and I am a technical program manager in the AI benchmarking team on Azure. Today, I will explain how to run ResNet-50, the deep learning model for image classification with MLPerf Training v3.0 on Azure's ND H100 v5 series. The training benchmark that we will use for this video is sourced from MLPerf Suite from ML Commons. ML Commons is an open engineering consortium of AI leaders that provides unbiased evaluations of training performances for hardware, software, and services, all conducted under prescribed conditions. MLPerf training benchmarks consist of real-world compute-intensive AI workloads to best simulate customers' needs. Today, I will be using an ND H100 v5 virtual machine. It is powered by the latest NVIDIA H100 SXM GPUs and 80 gigabytes of memory per GTU. If you don't know how to set up your virtual machine using Azure Portal or Azure Scikit-Learn Cluster, I invite you to start by watching the corresponding tutorials on our channel. Benchmarking with the MLPerf Training v3.0 consists of three main steps. First, we will set up the environment. Then, we will download and preprocess the datasets. Finally, we will run the benchmarks and compare the performance to the official results from ML Commons. Let's get started. First, we need to download the Docker image. An account on NVIDIA NGC website will be required to obtain the container. Then, Azure published the code publicly on ML Commons GitHub. Thus, we are downloading it with a simple git clone command. Finally, we can enter the directory specific to Azure. The environment is now ready for the second step. This step consists of downloading and preprocessing the data. First, we must download the training images as a tar file from imagenet.org. You will need an account to do so. Then, the processing of these images takes a few steps and approximately 10 minutes. Next, we will reproduce these steps for the validation images. First, downloading the images from ImageNet, then preprocessing them. We can now move on to our last step, running the model. All the configuration files are already adapted for our NDH100 v5 virtual machine. Running the model consists simply of sourcing the right configuration file for H100 GPUs and starting the job with Docker. The target accuracy is 0.759, and the metric for performance is the time to reach this target. You can find all the results from Azure for ResNet, as well as the other benchmarks on ML Commons website. For example, the official results that we published in June 23 was 13.8 minutes. You have now successfully run the deep learning model for image classification ResNet of MLPerf Training v3.0 on Azure. We hope you found this content useful and don't hesitate to follow this channel for more content on how to use Microsoft's HPC and AI offerings. Have a good one!